The statistics process. Here you have statistics spelled in Greek. Here's the sigma symbol, is song in Greek, and it represents some in statistics. It says the research topic, okay? Research question, the fundamental initiator of the research. It is the one that should be answered by first collecting data, and there will be variability in that data. The research project sets out to answer the research question, okay? And then you have what you call a hypothesis. A hypothesis is a supposition or proposed explanation, a statement or sentence, if you will, made on the basis of limited evidence as a starting point for further investigation. In other words, it is a possible answer to the research question with little or no empirical evidence. So therefore now, if you have a research topic, you have a research question, then you have a hypothesis, which is a possible answer to the research question. You've got to collect data, organize data, represent data, analyze data, and come back full circle to make an informed decision with regards to answering that hypothesis. Okay, to prove or disprove that hypothesis, to answer that research question. Yes? So then you have what you call hypothesis testing. The research topic again, all right? Hypothesis testing is the theory, methods, and practice of testing hypothesis by comparing it with the null hypothesis. The null hypothesis is only rejected if its probability falls below a predetermined significance level, in which case the hypothesis being tested is said to have that level of significance. The theory, methods, and practice of testing hypothesis by comparing it with the null hypothesis. So all this gives you a slight definition as to what is hypothesis testing when you have a research topic and you have a hypothesis with regards to a research question. Again, it says, reiterates, a hypothesis is a supposition or proposed explanation, a statement, a sentence made on the basis of limited evidence as a starting point for further investigation. So it's like a possible answer, all right? And it needs to be tested, okay? And that's what this presentation is all about, testing a hypothesis to see whether or not that hypothesis is true or false. A research question, as we said before, is the fundamental initiator of the research. It is the one that should be answered by first collecting data, and there will be variability in that data. The research project sets out to answer the research question. So that cannot be stated enough. That cannot be overemphasized. Again, a hypothesis is a supposition or proposed explanation, a statement or sentence, if you will, made on the basis of limited evidence as a starting point for further investigation. In other words, it's a possible answer to the research question with little or no empirical evidence. And then data has to be collected in order to prove or disprove that hypothesis. That hypothesis has to be tested. That supposed explanation has to be tested, okay? There are different approaches to test that supposed explanation, to test that hypothesis. You have the critical value or the classical approach, and you have the p-value approach. And you have the p-value approach using Excel or SPSS or some other statistical program. Okay, so we're going to discuss those approaches in this section. The hypothesis tests being studied in this course are 4 of them. So it's only 4 hypothesis tests we're going to discuss in this course. The z-test for mean, and here the symbol mu is used for mean, which is testing the claim made by someone regarding the mean of a variable. Okay, so you call that the z-test for mean. Someone makes a claim, someone says the hypothesis about the mean of a variable, and that hypothesis can be tested using the z-test for mean. Then you have the chi-square test, which is also called the goodness of fit, and we are going to do 3 versions of it. The chi-square test for variation. Oh, by the way, this is a Greek symbol, the chi-song in Greek, or the chi, and it's also called chi-square for variation. Chi-square for randomness, chi-square for independence. The chi-square for variation is testing whether there was a variation in the distribution of 2 sets of values, the expected and the observed. The expected will be historical, and the observed will be the present values. And you have the chi-square or the chi-square test for randomness, testing whether or not one distribution is random or not, or is affected by a factor. And then you have the chi-square test for independence, testing whether one variable is independent or has no association with another variable. So these are the 4 hypothesis tests we are going to study: z-test for mean, chi-square test for variation, chi-square test for randomness, and chi-square test for independence. Here we're going to discuss the critical or classical approach to hypothesis testing. The hypothesis statements for z-test for mean mu. Some will make a verbal statement regarding the mean mu of a variable, the population mean. Okay, the statements will be said in verbal form. To begin the z-test for mean, the statement will be written in mathematical form. So that statement, which is the hypothesis, will be converted from words to symbols. So I repeat, in the z-test for mean, the worded hypothesis will be converted to symbolic form or mathematical form. Here, the numerical value of the mean is represented by the value beta, right? So first step is to state a pair of hypotheses. All right, the first is called the null hypothesis, which is denoted as H sub 0, and the second is called the alternative hypothesis, denoted as H sub E. The z-test for mean mu, the statements are written in mathematical form, right? The worded form have to be converted to mathematical form. The null hypothesis is the status quo, H sub 0. It always carries the equal sign, okay? Always bear that in mind. Or the less than or equal to, greater than or equal to, or equal. During this decision time, the null is either rejected or not rejected in step 7. The alternative hypothesis, H sub A, it is the complement of the status quo, which is a null hypothesis. It is a statement that must be true if H sub 0 is false. It does not contain the equal sign. Okay, so the must begin with a pair of hypotheses for the z-test for mean, and the H sub 0 will always carry the equal sign. The H sub A, which is the alternative hypothesis, will not carry the equal sign. Here, this table will help you to convert word to symbols. Okay, because bear in mind, in z-test for mean, you have to convert word to symbols. So for example, the mean is less than or equal to that value v. And here is the symbol for it, because that's a H sub 0. Here is the H sub 0. The mean is less than or equal to v. H sub A, the mean is greater than v. The mean is greater than v. So these are the words and these are the symbols to facilitate the conversion of words to symbols for the z-test for mean. Then we have the hypothesis for the chi-square test. Okay, the chi-square test, both statements are written in worded form. Okay, so this conversion for words to symbol of the pair of hypothesis is not for the chi-square, only for the z-test for mean. So you have the chi-square test for goodness or fit. All right, chi-square test for variation. Here the H always saying the observed values are equal to the expected, and the null will be the alternative will be saying the observed values are not equal to the expected. So this will be the PA for the chi-square test for variation. The chi-square test for randomness, the distribution is random, occurred due to chance. The distribution is not random, affected by a distribution. Okay, so and then the chi-square test for independence or no association. This deals with the verification of association or not between two variables of a study subject. There is no association between variable A and B, independent of each other, and there is an association between variable A and B dependent on each other. So these are the null and alternative statements for the chi-square test. Okay. Then step 2, we have to sketch a distribution curve. For the z-test for mean, the curve is a bell-shaped curve. And for the chi-square test, the curve is skewed towards the right. Okay, that's step number 2. Step number 3, you have to locate and shade the critical region. A test can either be a one-tail or a two-tail. That's for the z-test for mean. Okay, the z-test for mean is the only one that should be two-tail. It can be one-tail or two-tail. The alternative hypothesis is proposed variation in only one direction. The two-tail, the alternative hypothesis suggests a different in either direction. For a z-test for mean, the critical region follows the direction of the sign of the alternative statement. The sign of the alternative statement can point to the left, right, or both directions. So these are the possible situations for the z-test for mean. But for the chi-square test for randomness, or the chi-square test for variation, or the chi-square test for independence, it will always be a one tail, it will always be a right tail. So where the z-test can either be right, left, or two tail, depending on the sign of the alternative. Bear in mind, is the sign of the alternative that conducts the tail for the z-test. So if the arrow pointing towards the right, it's a right tail. If the arrow pointing towards the left, it's a left tail. If the arrow is not, is a not equal sign, then it's a two tail. That's the alternative sign, bear that in mind. But for the chi-square test, it will always be right tail, okay? Then 4, you have to place the critical value on the critical point. Use a significant level of, or alpha, a significance level symbol to obtain the critical value from the probability table. Most probably for this course, you will be given the critical value. Plot the critical value on the critical point on the distribution curve. Yes, so that's step number 4. Then you have to calculate what you call a test statistic. You have to use a formula. That's the z-test formula, and that's the chi-square test formula to calculate the test statistic. And then you have to plot the test statistic on the distribution curve. You must look at the value of the critical value in order to plot the test statistic on the correct position on the line of the curve. Okay, and the Z, and number 7, decision time, reject the null if the test statistic is located in the critical region. Do not reject the null if the test statistic is not located in the shaded region. And there are 2 types of errors that can be made. The type 1 error occurs if the null hypothesis is rejected when it is true, and the type 2 error occurs if the null hypothesis is not rejected when it is false. And the 8th step, step number 8, conclusion time. If the null is rejected, then the alternative statement is the conclusion. If the null is not rejected, then the null statement itself is the conclusion. Always remember that you will start the test with 2 statements, the null and the alternative. After the test is done, only one will be the conclusion. Write out the conclusion in graded form. Okay, so these are the 8 steps for the classical approach of hypothesis testing. Yes. Eight steps for the classical approach for hypothesis testing.